Good day and welcome to taped lecture number 14 in MMVAZG 522 Total Quality Management. My name is Rajiv Gupta. In today's lecture, we are going to be covering primarily the topic of quality by design. And we will also have a brief introduction to quality function deployment, which will be covered more fully in lecture number 15. In today's lecture, as you see, we will begin with a brief recap of lecture 13, following which we will have a discussion on sequential versus concurrent design, which is what is very relevant to this whole business of quality by design. Then in modules 3 and 4, we will cover 4 aspects of quality by design, where we will cover things like teams, communication, implementation, and some of the tools that are used. In module 5, then we will talk briefly about quality function deployment, and then we will summarize what we have been discussing in module 6. So let's get started. If you will recall, lecture number 13 was the second lecture on the design of experiments. Lectures 12 and 13 were both dedicated to the design of experiments, and in lecture 13 we covered more specifically the multi-factor design of experiments. Primarily, when we talk about design of experiments, the idea behind the DOE or design of experiments is that we do not wait for something to happen in the system before we try to figure out what has made a change in the system, but we actually induce a change in the system and proactively test to see the impact of that particular change. The methods for the design of experiment that you will typically find in normal textbooks, including our own, is something that Deming never agreed with, and I do agree with Deming, because the approach in traditional textbooks really goes against the grain of basic statistical thinking. And so please, as far as this material is concerned, you should not be really following the material in the text, but rather the material in the lecture notes. The material that I have covered is something that is based on a book by Ron Moen. He, interestingly, was somebody who was asked by Deming to write a book on the design of experiments. And certainly Ron Moen was, who is a very ardent student and fan of Deming, wrote the book. Moen was, he used to be working with General Motors for many years. Now he's of course retired from there. But his book quite obviously does reflect Deming's approach to experimental design. What Deming really felt when he would talk about the various approaches to the design of experiments in the various textbooks is that they tended to ignore the difference between analytical and enumerative studies. In analytical studies, you basically try to predict future events, whereas in enumerative studies, you took a look at what a particular you took a sample from the current population which existed in its totality at the present, and you made some statistical statements about the total population on the basis of that sample. But when we talk about analytical studies where you are looking at the future represents a population that is never there all at the same time. So you can never really take a sample from that particular population, and therefore the kinds of results that most statistical books talk about really were something that Deming did not agree with. And he used to Deming's focus was on stability of the processes, which was determined by the X bar and R chart and the SPC charts, where he said that only when you have a stable process can you have predictable outcomes. And if you have a current process which is stable, its stability is only guaranteed for the present, and that is the reason why you need to maintain SPC charts. The moment a process goes out of stability zones, that is where we really cannot make any prediction with regard to that particular process, and therefore trying to make future predictions on the basis of a current sample is statistically incorrect. So the experimental design approach that we had followed in lectures 12 and 13 dealt with the PDSA approach, or the PDSA perspective, where we did an experiment, and based on the results of the experiment we formed a certain opinion with regard to the effect of certain factors on output of a certain type. And by doing successive experiments, we actually got strengthened our belief in, or the degree of belief in, the results of that particular experiment. And he said that this is about as good as you're going to get, and putting some numbers statistically in terms of 99-95% confidence, he said, made no sense, simply because those were actually incorrect statements to make for future events. In lecture 12 we dealt primarily with single factor design of experiments, where we changed only one factor, whereas in lecture 13 we dealt with multi-factor design of experiments, where more than one factors were changed and their effects were examined.